Hello, algebra students. In lesson 6 of unit 3, we're going to learn how to solve radical equations, capping off a unit that's worked with radical expressions and rational exponents, things of that nature. So now we get to the point where we get to solve equations involving those things. So here we go. Equations that have radicals, or equations with radicals that have variables in their radicands, such as this one, are called radical equations. Example is like the one we're about to solve. So, idea as always, in order to solve for x, is I want to get x by itself. To do that, I have to undo all the things that happen to x, usually in reverse order. So, if I were to think about plugging in a number for x, in this equation right here, I would multiply it by 2, then I would add 7, and then I would take the cube root of that number. So let's work backwards as we get x by itself. I need to undo the cube root. So in order to undo the cube root, I will cube both sides, raise both sides to the third power. Do something on the left, do the same thing on the right. Cubing a cube root will leave me with just the inside, which is 2x plus 7. And that's going to equal 3 cubed on the other side, which happens to be 27. At this point, once I've eliminated the radical from my problem, things get pretty easy. It's either going to be some sort of linear equation like this one, or maybe a quadratic equation that we'll run into very soon. Oops, sorry about that. So 2x is equal to 20, and then divide by 2. So x must equal 10. Plugging that in to check it out. 10 times 2 is 20, plus 7 is 27, and the cube root of 27 is indeed 3. This is a correct answer. Now this expression in the middle, 2x plus 7 raised to 1/3 power equals 3. Same equation, question mark? Actually, it is the same equation, just written using rational exponent notation. Remember, to raise something to the 1/3 power is the same as taking the cube root. So if I have a rational exponent, I'm going to undo that rational exponent by raising the expression to its reciprocal. So 3 would be the reciprocal of 1/3. 3 times 1/3 is 1. So I now have 2x plus 7 to the first, which doesn't need parentheses or an exponent. Now if I do something to the left side, better do the same to the right side. 3 cubed happens to be 27. You'll notice we have the same equation again. I'll subtract 7. I'll divide by 2. And x is going to equal 10 once again. So, a couple of ways to solving a radical expression or an equation with a rational exponent. And again, plug it back in. 10 times 2 is 20, plus 7 is 27. Raise to 1/3 power. Yes, that's 3. Good to go. Now, if the algebraic methods we've used here don't agree with you and you prefer to graph, well, graphing is another option that we might have here. If I were to do the same equation by solving it, I would think about it this way. I would graph the left side, the cube root of 2x plus 7. Maybe using a calculator, maybe using decimal, something like that. Right here I've got it graphed on a calculator by typing in on line 2, y equals the cube root of 2x plus 7. So you'll notice that in red on my graph here. Here's the cube root of 2x plus 7 graphed. So any point here is going to be a solution, or it's an output. If I plug in x, I get that particular output value. Well, I want to know when this is equal to 3. So on my graphing calculator, what I do is I type in a second equation, y equals 3. What happens is it's going to graph a horizontal line at 3, because that's what y equals 3 looks like if you graph it. So then I could use my calculator to find the intersection of those two lines, because at some point there's going to be some x value that when I plug it in, I get the same output in the first function, the red one, and the blue one. And that x value is going to be the solution to this equation. Now you can sort of scroll over there and maybe guess, but the best way to do that is to calculate, hit second, and then trace, which will take you to the calc menu. We're going to calculate the intersection, because I have two lines I want to find where they cross. So I'll hit 5 to choose that option. Easy questions to answer. First curve with the cursor highlighting y equals 3, and it tells me so. I hit enter to say yes. Second curve is now the red one with the matching equation up here, and you can hit right or left arrows to move around on them. If you want to change to a different curve, you hit the up or down arrow to do so. But I don't want to because it's on the right curve. I'll hit enter to say yes. Guess, if there's multiple places where they cross, then the guess becomes sort of important. I will just move my cursor over towards the intersection using the right arrow key repeatedly. When I'm good to go, I'll hit enter. And doing a lot of guessing, moving. And there we go. The intersection is at 10, 3. Of those two things, the important part to me would be the x value that I got, because that x value gives me the output that I need, the x value being 10. So 10 is the x value that worked here and on the graph.